Okay, so let's solve today's Leetcode challenge. Minimize maximum of products distributed to any store. This is the problem statement, and here is an example given. Let's try to understand this problem using an example. So I have created an example here. This is today's problem. So n equals to 3, n equals to 1. Quantities array with only one value at 0 index, which is 2. So as we have three placeholders, we will fill them accordingly. A1 would have 2 in the first container, 0 in the second, and 0 in the third. Max we would get is 2. For A2 we would have 1 in the first container, 1 in the second, and 0 in the third. Here we would get max of 1. We have to minimize the maximum of products. Maximum of products in these two was 2 and 1, and we did minimize them which way. So our answer will be 1 and this one. This is what the problem statement means. First solution I can think of is a brute force one. These are the constraints given to us. So brute force would be order of n squared and complexity around 10 power 10, which would not work. But still we would try to get a brute force solution out of which we can get an optimal one later on. So here is another example. So this is the quantity array given. Each container can contain values from 1 up to the maximum of quantities I, which is 5 here. Because it is given in the question that a store can only be given at most one product type, but can be given any amount of it. So that is why the maximum product type would be the limit here. And it can also contain zero number of products containers. So you would go from 1 to 5. So when I equals to 1, that means we have one container. So that means we can keep one item in every container. We would get 11 containers. 5 plus 4, 9 plus 2, 11, 11 containers. It cannot be our answer as it is less than our count, which is 5. I equals to 2. We would require 6 containers. 2, 2, 4, 2 plus 1, 3. 2, 2, 1. So 5 containers. Basically, we are calculating ceiling value for every nums of I, dividing it by the amount we can store, which is I. For I equals to 3, we would get count 5, 3, 1 remaining, so another one. So this is greater than equal to our term. I equals to 3 would be our bottleneck condition. After that, even if we increase our quantity we can store in the container, the count of containers would only decrease. So it would always satisfy this condition. That is why I could just use the bottlenecking. Basically, from 1 to max of quantities array, we are finding out the first bottleneck, which would be our answer. We are doing this linearly in our brute force approach one by one. First, we are taking IOs 1, then 2, then 3. So that means for every value, we got a linear time complexity. The total brute force time complexity was order of Q queries in the quantities array into max of the Q quantity, just 5. Now, optimal approach, which is binary search. We know this is our search space from 1 to max of quantity, and that is in increasing order as it is mentioned here that all this will be integer values inside the quantities array. So as this is an increasing sorted order, we can apply binary search on it. This will be our left, this will be our right, and then we will calculate middle value and then compare it with the bottleneck, which is our given container should be less than equals to n. So if count from this mid value comes out to be 5, then it can be a possible answer as n was 5 here. So we will eliminate the right half of the search space to get even the smaller bottleneck if it is present from the left portion of the binary search. Else we'll eliminate the left half if it comes out to be more than 5 containers required to decrease this more than 5 to 5 or less than 5 and shift our left pointer to mid plus 1. Here time complexity would be order of q into log of max value and space complexity would be order of 1. So let's code up the solution now. This would be the helper function to check if this number of containers is even possible for us. Left right pointers initialization was 1 and max of quantity result count is 8 while integer division to. Now if is possible of x, then we will store count as x and try to find out an even less value if it is present in the left part. Otherwise, we would just return count. Now we'll complete this function. Number of stores equal to 1. Please leave it equal to 1. Number of stores would be field value of bbye. Return if stores are less than equal to. Now let's run code. Okay, there's a spelling mistake. Now it's passing all during test. At least the default one. Yes, so it's solved. Let's meet tomorrow. Bye bye.